Hello students. Today now we will go to part 2 of linked list. Let me share the slides. So in part 1 we have defined what is a linked list, and we have shown that a linked list contains of nodes, and these nodes are of type self-referential structure. Each node can have some data field, and it has a pointer to a node of the same type. And using these nodes, we can connect them to get a list. Now we will look at programs and codes to look at the particular operations that we can do for a linked list and how it works. So we will look at how we can create a list. So to recapitulate, let us assume that this is my structure for a list. We have these three data fields: role, name, and age. And we have a field called next, which is of type pointer to struct stud star. And we have defined struct stud, the type of struct stud, we are calling it a node. Now, let us say, that head is of type node star. So we have defined node star head. Now we can use malloc to allocate space for storing a node. And this malloc returns an address which is cast to node star and assigned to head. So this malloc, this statement will give us the following thing. We will get space for this structure allocated, which has three data fields and one pointer field. And head is a variable which will point to this structure. Now, so we have this created the first node, and we have head pointing to this first. Now, if there are a number of nodes in the list, suppose there are n nodes in the list, then we have to allocate n records one by one, and we have to read the data in these records, and then we can modify the links so that the chain is formed. So if we have to create this list, we see that there are three records. Correspondingly, we have to create these three nodes by calling malloc, and we have to set these pointers so that we can set up the list. Now, let's look at the code. So we want to write this function to create the list and to set up the list and to create the head of the list. So this is a function create list, and we set it up so that it can return the head of the list. That is the address of the first node of the list. So this function create list returns value is of type node star. So here are certain variable definitions which we will use. Now first we take from the user how many nodes we require for the list. So the user gives a particular number, we read that number in n. Then we will run this for loop. In the for loop, we'll be creating n nodes. So if in the beginning, first we have to get the first node, and then we will get the remaining n minus 1 node. So if k is 0, that means we have to set up the first node, And that first node, this address we will store in head. So we say head equal to malloc size of node, and we cast it to node star. And P is the pointer that we will use to traverse the list. So we initialize P to head. Head is a variable which will keep track of the address of the first element of the list, and P is a variable that we will use to traverse through the list. Now, this is what we do for the first element. Subsequently, for the remaining n minus 1 element, this is what we do. P was the previous element, and we get P arrow next equal to node star malloc size of node. So what for k equal to 0, what we have got is that we have set up this node. We have let head to point to this, and initially P also points to this. Then when k is 1, what we will do? We will say P arrow next is malloc size of node. So we will get another element using malloc, and we say P arrow next will now point to this element. So we do not need additional variables. And then for this particular node, we will uh, read, for all these nodes, we will read the data fields. So in the particular stood record, what we had 3 fields, role, name, and age, and we will be reading these values. Then when I get k equal to 2, again what we will do? We will again allocate space for this list. We will say, now, in the previous one, P would have now come here, and the previous P would have been lost. Now we will say P arrow next equal to this malloc, and then we will populate the data field, and then again we will continue. So this will be my new P, and we will continue. So until we get k equal to n minus 1, so we will get the last element. So this is what this function does. And at the end, when we have reached k equal to n, we will come out of the loop, and we will set P arrow next is now. Now this list has been set up, and we will return head. Head, if you remember, was pointing to the first element of the list. So let us look at this again. This is a function CreateList, which will create a list having n elements, and it will return the address of the first element. So we have defined head and P of type node star. Head will contain the address of the first element, and P is another pointer which we will be working with. Now we have this for loop, and we go through this loop n times. First time we use malloc, and we create the head first element, and we let head point to the first element, and P is also initialized to the address of the first element. Subsequently, we'll be using malloc and to get this data, and then we will have the previous element point to this element. And for each of the nodes, we'll be reading the data fields and populating the structures. At the end, when we come out of the loop, we have P pointing to the last element. We'll have P arrow next equal to null to signify the end of the list. So if k is equal to, if we want to create, if n is equal to 4, this is the type of list that we will get. Now this function we can call from the main as follows. We have to define head to be of type node star, and we can say head equal to CreateList. Now CreateList function will be called, and this function will return the address of the first element of the list, and we can keep it in head. And now we can call a function such as traverse, which we saw in the first part. We can say traverse head in the main to print the elements in the linked list. Next, we will look at the other operations that we can do in the linked list. After creating a linked list, either as one element linked list or an element linked list, we can add or insert new items into the list. And you can delete items from the list. First, let us look at a simple example showing insertion. Suppose this is a list that you have, and this is a node which we wish to insert. X is the data item in the list, and this is a particular node that we have obtained. And suppose we want to insert X between A and B. What do we have to do? Now A is pointing to B. If we want to insert X after A, we will now have A point to X. And X arrow next will point to. Then we will have a new list which has A, then X, then B. This is exactly what we do. So we have to, if we want to insert X here, we must manipulate the pointers so that A points to X, X arrow next points to B. And in order to do that, we must have an access to the address of the element after which X has to be inserted. So if you wanted to insert after B, what will we do? What we would have done is that suppose we have another node, let us say Y, which we want to insert between B and C. We must have a pointer to B. Using that pointer, we can say B arrow next is now Y and Y arrow next. This is how insertion can work. We can also may have to insert at the beginning of the list before A and at the end of the list after C, and we can work out those cases. Suppose Z is to be inserted. This new node containing Z has to be inserted as the first element. What do we have to do? We have to have Z arrow next point to where head is pointing. And we will have head point to Z. Similarly, if you want to have W at the end of the list, what we should do? We should have a pointer to C, and we should say C arrow next equal to W, W arrow next is now. So this is how insertion takes place. In order to insert a node, first we have to allocate space for that node using malloc. We have to populate the data item, and then we have to manipulate the pointers so that we have the list set up. And in order to do that, we must have a handle to the element, to the node after which the new node has to be inserted. We will look at code for this soon. So this example is for insertion in the middle. We will look at insertion in the beginning and end later on. So if you want to insert in the middle, we need to manipulate some pointers. So let us say if we want to insert between A and B, suppose Q is a pointer to A and P is a pointer to B. So P is of type node star, Q is of type node star. And this is the node that we wish to insert. And new is a pointer to that node. How do you get this node? We can get this node by malloc. So we can say new equal to malloc size of node. And new is it's of type node star. Now, once we have done that, what do we have to do? We have to have Q arrow next point to new. So this is what we do. Q arrow next equal to new. And then new arrow data is X, that is we are populating new. And then we say new arrow next is equal to P. P is the previous item. So if we did not have P, what we can do is that before we start, we can say P equal to Q arrow next. So these are the two pointer manipulations that we have to do. Q arrow next equal to new and new arrow next equal to. Next, let us look at how to delete a node from a list. Suppose this is a linked list, and suppose this is the item that we wish to delete. So the node containing B is the node that we wish to delete. What do we have to do? Simply, we have to skip B. That is, for this node P, we will have P arrow next was earlier pointing to B. We must have P arrow next point to C. How do we do that? Where do we get C? C is P arrow next arrow next. We should say P arrow next is P arrow next arrow next. And then, very important, now this B is lost. We must free this memory. So in order to free this memory, we first keep track of, we must remember the address of B, because once we change this A arrow next, B will be lost. We must remember this address, and then we can use free, we can call free to release this memory. So let's look at the code fragment. So if Q is pointing to the previous element, because B is what has to be deleted, Q is pointing to previous element, we can say Q arrow next. This is Q arrow next is now this one. Is Q arrow next arrow next. What is Q arrow next arrow next? Is this element. So we say Q arrow next is Q arrow next arrow next. But there's a problem. Once we do that, we will lose B. So before we do that, we must remember B. We could also have, if you had this pointer, we could have also said Q arrow next equal to P arrow next. So you have, if you remember A, then you can free P. So what we can do is that if we had only this Q, we can say P equal to Q arrow next. So P is pointing to B. Then we can say Q arrow next equal to P arrow next. Then we can say free. So this means this memory will be released, right? So earlier we had a 3-element list which are occupying 3 nodes. Now we will have a 2-element list, and this item can be released. So now let's look at a comparison between array and list. So arrays are very good if you want to insert items at the end of the array or delete items at the end of the array. So array, you have different items. So if you want to add an item at the end, it's very nice. If initially size is n, you say n plus plus, you add this element. But if you want to delete an item from the middle of the array, there's a problem. Not problem. What you have to do, you have to shift the elements. Rest of the elements will be left. So array is good for inserting and deleting at the end. You do not have to have any shift. Otherwise also it is possible, but then you have to do the shifts. Secondly, arrow is very good for randomly accessing array. If you have an array of size 1000, if you say, suppose the array name is A, if you say A 501, immediately you get the 501. So this is a random access structure. Array is also good if you want to search for a particular value. Suppose you have an array containing n items. We can search for an item in the array by looking at the different positions in the array. Now let us see what linked lists are suitable. In a linked list, we can insert an element anywhere in the list if we get a pointer to the previous element. Similarly, if we get a pointer to the previous element, we can delete an element from the list. Linked lists are also good for applications where sequential access is required. In array, you can go to the ith element directly. In the linked list, if you want to go to the ith element, you have to start from the head, then go one by one, I steps until you reach the ith. So if there are applications where you only mostly do sequential access, linked lists are good for those situations. And linked lists, very importantly, linked lists are used where the number of elements cannot be predicted before. In those conditions, we prefer to have linked list, because if you use array, we have to pre-allocate memory for that array. Now, there are different types of lists. Some of this we will see later. Now, the simple list that we have shown previously is called a linear list, linear linked list, or singly linked list. Right? And what we have here is we have a pointer to the first element of the list, which is our head, and then each element points to the next element. Only a single pointer is there, and the last element, the next field, points to null. Now, in certain applications, for example, we will see in queues, we can use a circular link list. And a circular linked list is also a linear list, but the last item contains the pointer of the first item. So there is no null, there is no last, no grounding. So a circular list, from the last item, you can get back the first item through this. So this is called circular linked list. This is also a linear list. The next type of linked list which you can use is a doubly linked list. In a single linked list, you can go from an item to the next item. You cannot go from an item to the previous item. So if you are given a pointer to an item, if you want to find the previous item, you have to start from the beginning, traverse the list until you get an item whose next points to. But in a doubly linked list, we have two pointers. Actually, that means we have two pointer fields. So, typical structure will have one data field or one or more data fields and two pointer fields. One of the pointer fields will point to the next element. The other will point to the previous element. Okay. And we can also maintain it as a circular list, so that the next of the last element points to the first element, and the next of the first, and the prev of the first element points to the last element, if you wish. So typically we will keep two pointers. People usually keep two pointers, not necessary, but they keep two pointers, head and tail. Right? So you have two sets of pointers. Let us call them next and prev. So the next pointer, so this is the A arrow next points to B, B arrow next to C arrow next will point to A. And similarly, A arrow prev points to C, B arrow prev is A, C arrow prev is B. So in a doubly linked list, you can go both right as well as left. Now, these are certain operations, standard basic operations that you do on a list typically. First is creating a list. 2 is traversing a list. 3, inserting an item to a list. 4, deleting an item from the list. And then there can be other functions such as concatenating two lists into one list. We will see the code for some of this. Before we do that, we can I want to tell that we can view a list as an abstract data type. What is an abstract data type? First of all, abstract data type is typically a user-defined data type and is often more complex than simple data types like int, float. So when you define an abstract data type, you have the fields of the data type and you define the functions on them. These are called the interface functions, and using those functions, you can manipulate the data. So suppose you have a list, you can define the operations on the list. You can define how to create a list, a creator or constructor operation to create a list. You can define operations to access elements of the list, for example, the first element of the list. You can define functions to insert an element, functions to delete an element, functions to traverse, and so on. And once you have defined the function, you can use those functions to access the list. So why is this called an abstract data type? Because when you have So you have this structured definition, you have the functions defined, and once you have the functions, the user program or user program will only call these functions. The user program does not call directly the structure. So this is a structure. These functions manipulate this structure. The user program only works with the function. So this is why this is called an abstract data type. This notion is called an abstract data type. We will see more examples of abstract data type in the lab. So in abstract data type, when you do some operations, you just call the function. And these functions have been already implemented for you. And so you need not know how exactly the data is structured, how exactly the functions are written. All that you do is to you call these functions. You know what the function will be. For example, suppose you have the string data type and there are several functions which have been defined in the library, like strcat, str, cmp, str, len. You can use those functions without looking at how those functions have been defined. So you can also set up a structure with the data type. You can define the functions so that a user who wants to access the data can only call these functions. So in an abstract data type, the details of the implementation are hidden from the user. When you do some operation on the list, say insert an element, you just call a function, and the details of how the list is implemented or how the insert function is written is no longer required. Now, if we look at the list as an abstract data type, these are certain standard operations: insert, delete, traverse. So this is a list. You can define these functions. You can also define other functions like create, concatenate, etc. Now, uh, first let us look at how to traverse the list. So once the linked list has been constructed and head points to the first node of the list, you can follow the pointers. We have already seen a function for traversing the list. You can follow the pointers. So suppose you have a list like this. Suppose this is the list and you have a pointer to the head of the list. Now what you can do is that you start with head and you come to the first element, you print that element. Then come to the next element by following the pointer, print this element. Come to the next element following this pointer, print this. Come to the next element, print this. Next element, print. Next element, print. And you can do this using a loop. So let's look at an example function. So this is the function display, which takes as parameter head, which is of type node star. So we have also defined p of type node star, and p is initialized to head. Now this is my loop. In this loop, we will go to the element one after the other and we will print the content of this. We've also defined a variable called count. Now this is what we do in the loop. We print the value of count and the data fields of the current node. The current node, we have p pointing to the current node. So we can get p arrow role, p arrow name, p arrow edge to access these three fields. And we can print them. We increment the value of count and then we say p equal to p arrow next. So like this, we can now go through this loop until p becomes null. By this time, we would have printed all elements of the list. So you have this list. So you start with head. You initially count is 1. Count is 1. Then you print this. Then you make count as 2. And then you follow the pointer. You come to this node. Now you print 2 and this element. Now we set count to 3, etc. And then print this, set count to 4, then print this, then you get null, you come out of the loop. And this function can be called from the main function as follows. We have defined head to be of type dot star, and we can call display head to traverse the list and print the elements. Now let us look at more detailed code about how to insert a node in a linked list. Now let us define our task as we want to insert a node before a specified node. Suppose we say that we want to insert a node before a node which has a particular role number. So we find a key of, so we have this data fields. For example, we have this role, name, age. Let's say we use the role as the data field and we want to insert a node before a node whose data field has a particular value of role. Now, this is in the programs that we will write, we will adopt the following convention. If the value of role is negative, then the node will be inserted at the end of the list. Now, this is the item that we wish to insert. And suppose this is the list that we have, and this is the item that we wish to insert. Now, there are 3 cases if the node is added at the beginning. So, suppose, the first structure, its roll number is the roll number that we are looking for, which means n has to be added at the beginning of the list. So, what we will have to do in order to do that, n arrow next will now point to the previous value of head, and now head will point to n. So head will point to the new node, and the new node will point to the previous first element. So this is inserting a node at the beginning of the list. Then how to insert a node at the end of the list? Again, we need to modify 2 pointers. The last point node, this is the last node. We have to get the pointer to the last node. And now we have to make the last node point to this new node, and this new node will now point to now. Okay. So this is what we have to do if we want to add a node to the end. What if we want to add a node in the middle? So suppose N2 is a particular node and we want to insert, before N2 we want to insert this particular node. We must get a pointer to N1, and we will, as we have already discussed, we have to manipulate these pointers as follows to get this N in the middle of N1 and now let us look at the code for doing this. So this is my function insert, and I am giving a list, and we have to insert an element in the list before a specified. Now I want to pass to this function the head of the list. So earlier we have seen that head was of type, address of the list. Now why have we put star head? So what we are passing to this function is a pointer, is the address of this head, not this head, address of this head. Why? Because head itself can change. When can head change? if you are inserting a node in the beginning of the list, the head will change. So because the head will change, if we did not pass a pointer to the head, this head would have been lost. So when we write this function, we pass to this function the address of the variable which keeps the address of the first element. So if this is my list, when I call this function, I will call it with insert address of head. What is head? Head is of type pointer to the structure. And I am passing the address of it. Why? Because the value at head I might change in the function. Now let's look at my function. We have defined p, q, and new of type node star. And then we have a couple of other variables, k and r no. K is initialized to 0. First, if you have to insert a node, we have to create the node. For that, we give a call to malloc and we store this in new. Now, we ask the user about the data of this node and we read in new arrow role, new arrow name, and new arrow edge. So we ask the user the value of roll number of the node before which this node is to be inserted. And the user must give a negative number to signify that this new node will go to the end of the list. Now, what we do is that we have got head is of pointer to node. That is, the head is the address. Head in this function is the address of head is the main function. And we get P to be the content of the head. So the P is this. Now using P, we can traverse the list. If P arrow roll number equal to the number that we are looking for, if the first element itself contains the roll number that we are looking for, then the new element has to be inserted before the first element. So if P arrow roll is roll number, we say that new arrow next is equal to P and star head equal to new. In this function, we will put the star head to be the new. So we have already explained why this argument is a pointer to pointer, because we want to pass the address of the variable which stores the address of the first element of the list. Now, we'll look at the else case. The first case was when the first element contained the roll number. Otherwise, we traverse the list and we use two pointers to traverse the list. These two pointers are P and Q, and these pointers Q and P point to consecutive nodes. So initially we have got P, which is pointing to the first element, while P not equal to null and P arrow roll is not equal to roll number, we say P equal to P arrow next. And we also remember the previous P as. So we maintain two pointers. Just a minute, let me erase this. So we always maintain two pointers, P and Q. So P is the current node, Q is the previous node. So when we go to this loop again, we will say P equal to P arrow next, and we will remove this, and this we will store as Q. Okay. And when do I come out of this while loop? Either when P arrow roll number equal to roll number. Let me just so when we do we so we come out of the while loop if either P arrow roll number is equal to roll number, or if we come to the end of the list. So either P is here or P is here and this roll number matches. So there are these two cases. Okay, now let's look at each of these cases. If P is null, sorry, this one. So if P is null, Q is this. So what we will do, we have to now insert the element at the end. So this is my new node. So I will say Q arrow next is equal to new and new arrow next is equal to now. Okay. This is inserting at the end. Now, what is the other case? The other case when we come out of the for loop is when P arrow roll equal to R. So here we are checking for it. Else if P arrow roll is equal to R number, then we have to insert in the middle, and we have already seen how to do this. So suppose we have, this is my P and this is my Q, and P arrow roll is equal to roll number. Now we have to insert new in between them. So we say Q arrow next is equal to new and new arrow next is equal to. This is the insertion in the middle. And this function can be called in the main lines. If head is of type node star, we can call insert, and to this insert function, we pass the address of head. Why? Because the head may itself get changed. When will head get changed? If a new first element is added to the list. You can implement a linked list so that the first element never gets changed. Right? Only second, third, etc. can get changed. In that case, you need not pass this pointer. You can pass head directly. So sometimes when we work with linked list, what we do is that this is the head and this is the list. So what we can do is that, so if you want a 4-element list, we maintain the first element as a special element which does not contain any data, which cannot be changed. And the second, third, fourth, fifth, these 4 elements contain data. Now, if this element is fixed, then all our insertions, deletions, etc. will be after this element. This element does not have a role to play because it does not have a data. In this case, the head cannot get changed in the function. But otherwise, because the head can get changed in the function, that is why we are passing this. Okay. Next, let us look at how to delete a node from a list. So let us say we want to delete a specified node, say a node whose role field is given. So again, we have to worry about 3 conditions. One, when we want to delete the first node. Second, when we want to delete the last node. Third, when we want to delete a middle node. Okay, so we want to delete the first node is case 1, third node is case 2, and the middle node is case 3. Now let's look at this function. So again, because we can delete the first node, if we delete the first node, head will change. So we are passing a pointer to the first element. So that's why we have defined head to be of type pointer to node pointer. Okay. So we want to delete this, and we have 2 pointer variables P and Q, and we accept the value of R number from the user. We initialize P to be star head, and then using P we can traverse the list. So first, if we have, this is part of the program only. If P arrow roll is equal to R number, that means we have to delete the first element. So what do we do? So actually this, our head is not pointing here. Our head is pointing to an element which points to N1. So we get P equal to star head. So this will be my P. Now if P arrow roll equal to R number, then star head, what is star head? It's P. So star head will be equal to P arrow next. What is P arrow next? This is P arrow next. So now star head, the content of head will be pointing to this, and we will free P. So P will be freed. Delete and deallocate the space points. This is for deleting the first. Else, if what are the other two cases? If we have to delete a last node or an intermediate node. So we have this while loop to traverse the list. While P not equal to null, P will be equal to null when we reach the end of the list, and P arrow roll not equal to R. We can also exit the list if P arrow roll is equal to R. So if these conditions are true, then we traverse the list as we did previously. We say Q equal to P, remember the previous pointer, and P advances, P equal to P arrow next. So we will maintain a pair of pointers Q and P. P is the current node, Q is the previous node. Now there are two cases. If P is equal to null, then we have reached the end of the list. The element is not found, and therefore we print that there's no match, deletion did not work. Else, if P arrow roll is equal to roll number, if we exit via this condition, then what do we have to do? We have to delete the node P. And in order to delete the node P, what do we have to do? Suppose this is my P and this is my Q. So what we have to do is that we will say Q arrow next equal to P arrow next. And we have to free the space for P. So this is for deleting an element in the middle. We say Q arrow next equal to P arrow next, and we free. Now this is a sample main function. Head is of type node star. We are calling CreateList to create a list which returns an address, which is the head. We call display to traverse the list. We call insert, and within the function insert, we can insert element into the list, and we are calling insert with the address of the head. After insertion, we are calling display to print the current list. Then again, we are calling delete with the address of head to delete an element if necessary. And then we again call display to display the print the new list. Okay. Now, these are certain exercises for you to try out. I will request you to work on them at your home. And if you have any queries, please write to me. If you write to me, if you have some difficulty, if you send email to me, then we will discuss these functions. But if you do not let me know, then we will not discuss. I will assume that all of you are able to do this. So the first function is you have to write this function concatenate, and this function has two parameters. Head 1 and head 2 are pointers to two linked lists. So you have to concatenate these two nodes and return the head of the new list. So what you will have is head 1 will, this I'm just, suppose this is a linked list, not an array, this is a linked list. This is another linked list. So what you will have to do is that you have to concatenate the list. That is, the last element here will point to this element here, and we will get this new list, and your function will return the address of this new list. So this is the function concatenate. The second exercise is to write a function to insert an element in a linked list in sorted order. Assume that the nodes in the element are placed such that the data items are sorted. Now, when you insert a node, you have to make sure that the list stays sorted after insertion. So this is the function insert sorted. This is a pointer to pointer, basically contain the address of the head node. And this is the new element address of the new node which is to be inserted. And this element must be inserted in the list such that after insertion, the list will remain sorted. Third function. So we always insert elements at one end and delete elements from the other using a queue structure. So you have to insert, you know, so for this, we will discuss this in the next class, how to work with a queue. And so what we want is a structure so that in one end we will do insertion, the other end we will do deletion. And what we will do is that we will insert an element at the end of the list, and we will always delete an element from the beginning of the list. And for this, you have to write these two functions, insert at the end and delete from the beginning. And so this is the third exercise. Fourth exercise is that you have to implement a circular linked list. I showed you the picture of a circular linked list where the last item points to the first item. And for the circular linked list, you have to write the functions to insert, delete, and traverse. Fifth problem is to represent a polynomial as a linked list, where every node will represent a term in the polynomial and will contain the values of n and an. Write a function to add two given polynomials. Some of these exercises we will discuss in the next class. So I will stop here today. And again, as I repeat, so please go through the slides on LinkedList. Try to understand this. Try to write some basic practice problems. And if you have any queries, any doubts, please send me email. I tried sharing a Google Drive with you, it did not work. So please send me email, and then we can discuss those in a live session or a recording session. Thank you very much. Have a good day.